I've not been able to make many of the talks, but Josh does work near and dear to my heart in terms of rating. I've been interested in rating teams and players, and Josh does that in this environment. And it turns out we have a friend in common. So Josh and I have kind of exchanged emails, been out to lunch since he got out here. One of the professors he worked with at Brigham Young is a good friend of mine who's also interested in rating teams and the likes. So I really had a great time when I talked to Josh about what he's doing and the challenges of trying to rate players as you accumulate information to set up fair teams, fair games, fair competitions. Real challenge, and the online world is a unique opportunity to do this. We like to set up games in college football or whatever, but we don't get to do that very often. So it's our great pleasure to have Josh Menke here to deliver the talk. And I'll add my thanks to Magda for his help in pulling the seminar series together. It's been a big winner for the school. So, Josh? Thanks.
You guys hear me okay? Yeah. Okay, so just to warn you, my talk won't be nearly as pretty or as exciting as, say, Rob Pardo or the last ones. It's more, I didn't put a whole ton of math into it, but, and the slides, the style of the slides seem familiar to previous talks, it's purely intentional. Anyway, I'm a systems designer, I'm not an artist, I'm not a level designer, so I don't do the presentations as much. So, okay. So let's talk about matchmaking and ladders, and by ladders is just another way of talking about rating and ranking people. That just went right on there. So who am I? Like I was introduced, I'm Josh Menke. I'm Blizzard's matchmaking and ladder designer guy. I guess my official title is senior designer 2. It was just like the title that seemed to fit for HR, but basically what I do there is anytime any of the teams at Blizzard want matchmaking or want to rank people, I usually end up talking to somebody and often also programming something up, because the math associated with matchmaking and with ranking players is a little bit not usually the usual type of math you get in game engineer's education. So they'll give me an API, I'll write the inner math, and then we'll go from there. The other fun thing that I was saying about the math here, a lot of math where you're dealing with statistics or machine learning, a lot of the programming you do, you can write these nice programs and read a paper and implement it yourself, and you run it and it seems to be working great, but like most of the time it's not the first time you put it up. There's always a bug. But the fun thing about these algorithms is they seem like they're working, and you don't find out until 10,000 players have tried to use your system or something like that. So just something interesting why it's helpful to have some background and experience in this if you're interested in ladders. Make sure it's why I tend to do the programming. I'd love for them to learn more about the engineering, but let's save it for this way. What have I worked on? So at Blizzard, if any of you have done World of Warcraft arenas, I did the current matchmaking for World of Warcraft arenas. If you go and say find an arena match, 3v3, 5v5, 2v2, there's some stuff I wrote behind the scenes that is figuring out how good you are, finding who you should play against. I also helped out in their rated battlegrounds. It's basically similar to what they did with arenas, but there's issues because arenas, the biggest teams you get are 5 versus 5, and battlegrounds you're looking at 25 versus 25. So we have to ask different questions about how we're going to arrive at their skill. But I worked on that. So if you have Cataclysm and you've done rated battlegrounds, that's also matchmaking behind there. I also helped kind of revamp how they were ranking people in arenas, which we moved over to battlegrounds. So I'll talk a little bit about that. And then I also do Starcraft 2's matchmaking and ladders, and I'm doing some stuff with Diablo 3, but there's not a whole lot we've said about it yet. Also, before I was at Blizzard, I was at a different company, and before that I was at eBay. And before that I was working on a mod. I don't know, has anyone here played Wolfenstein Enemy Territory? But a couple of you. Okay, so some of you will understand. So we started a mod. I'll give a little more information on this, but there's a mod called ETPub I worked on. A mod in this terms is, for Enemy Territory at least, it's a Quake 3 engine game. And when you mod Quake 3, you're either talking about making maps or you're talking about changing the game code. And I was changing game code. So it was written in C, and we wrote a lot of fun, really big functions in C and really big files. So it was fun. I'll talk a little bit about that too. I did the skill-based team balancing that. And I also did something not really related to this talk, which is called lag compensation, which if any of you played first-person shooters, you've probably experienced this. Most first-person shooters out today, when you shoot at somebody, you're shooting at that you're seeing them at where they were in the past sometime on the server. And so hopefully, if the server's smart, when you shoot, the server remembers when you shot, kind of rewinds time to see if you are shooting, if he was there when you shot. It has ramifications like if you run around the corner, sometimes you think you're around the corner, but you still get shot. But it's a trade-off. You can't get rid of the lag entirely, the ping, the latency. So you have to ask yourself, and this is something that'll be kind of a theme in my talk, is for your game, does this make sense? In your game, what do you want your players to experience? Do you want players to hit what they shoot at, which I kind of like, or do you want your players to be able to dodge better and get around corners? Is it a more defensive game or a more offensive game? Or another thing to ask yourself is, has anyone here played Modern Warfare 2, or Modern Warfare 3? In those games, you can replay your death, so that makes it blindingly obvious if you were around the corner or jumped out a window or something when you got shot. You might think that's what you'll see on your screen. You'll be like, how did I get hit? Because I can see myself not in his aim. So anyways, the theme of my talk will be thinking about the players, of course, which is I think the theme of Blizzard in general is kind of gameplay first there, and adapting to your audience of the game. So along these lines, my talk is design motivated. The goal in matchmaking and ranking is that the players have fun. Secondary is to make it fair. That might sound weird. You might think it has to be fair. It's not fun, but it's really about player perception. Sometimes things that are perfectly fair to players don't think they're fun. They end up not being fun. So that's something to think about when designing the systems. First, think about what's fun, and then in your mind, if you know the math, you can translate into, is that mathematically possible? Like, for one thing, in matchmaking, the most fun matchmaking is if you win 80% of your matches. That's not mathematically possible, unless we're matching you against computers. So, but think about the fun first and see if you can get there, and if you can't, then do what you can. But that's just kind of a point here, is that the main goal is to be fun. And I'll talk about some other points along those lines. And related to that, so ladders are related to matchmaking. When you do matchmaking, you're putting numbers on people, and you're using those numbers to figure out how good they are and who to play against whom. And it's really tempting and sometimes correct to rank people with those numbers. But it can sometimes also be really boring. But it's important to understand the interaction between those systems. I always say this, that a perfect matchmaking system would instantly know how good you are, and that number would almost never change unless you do change. But that may not be exciting as a player, depending on the type of game you have. If we give you a number and that number never changes, the player has no sense of progress. So things to think about, depends on the type of game, and I'll give some examples. But it's important to note that that's not always a one-to-one thing. You don't always just use that rating as your rank. If your audience is making players have fun with it. If you're in kind of the sports arena like Hal is, then you have this situation where you actually just really do want to show those numbers and show people different skill. And because those players in those different sports aren't going to read those and think your statistics aren't any fun. But in this case, it's the metagame for the players. So kind of a little outline here. I'm going to talk about how I got to where I am. And I'll talk a little bit about Wolfenstein Enemy Territory, because that's kind of where I learned a lot of what I learned about matchmaking and ladders and stuff. And then this is sort of like a brief history or brief summary of some of my biased experience in different types of how you get into games with people and matchmaking. So there's rooms and channels. Enemy Territory is a dedicated server list. I'll talk a little bit about that. Quick play is kind of what people do these days, and I'll give some examples from Blizzard. So how did I get into this? So I was finishing a PhD in machine learning, a lot of kind of neural network stuff, and some friends of mine who, so I went to Brigham Young University, which is partly a church school, and we would go to church together. Sometimes I'd hear them talking about, hey, we want to set up this Enemy Territory server so we can play each other, but they couldn't figure it out, and the friend who they were trying to set it up on, he was in a cable network. And cable back then, even today, did not have anywhere near enough bandwidth to run a server for this game. So I helped them set up a server, and I set it up on campus because I was living on campus, and we had 2 dedicated DS3s, which is 200 megabit lines, for our campus, which were close to the backbone. So pretty soon we had nonstop 32 people playing from all over the world, as far as Estonia, on our servers, and having a good time playing Enemy Territory. And so then the next thing, me being kind of a more kind of statistics type guy, I kind of wanted to rank everybody on the server, find out how good everyone was. And of course, I knew my friends were the best, so I wanted to make sure however I ranked them, they were ranked the highest. They were pretty good. I don't know if very many people came on our servers that were better than my friends. They were pretty good. So I wanted to rank them the highest, and so I kind of got into different ways of grabbing the logs and ranking them, and that was okay. I'll talk a little bit about, I think, what happened there. And then I started working on this mod called ETPub, where we were trying to replace a mod that had been left behind with no source code, and we were just trying to replace its functionality. And I ninja'd in a bunch of stats and team balancing stuff in there. I had a good time. And while I was doing this, I was like, man, this is kind of fun. It seems kind of like statistics. So I went and talked to Shane Reese, who Dr. Stern knows, his friend at BYU, and I said, hey, is this, can you do research in this area? And then he said, well, look at this paper I just wrote where I was ranking NASCAR drivers. And I said, you can do research in this. This is cool. So I decided I wanted to, he could rank NASCAR drivers. Why can't I rank players? If you read Shane's NASCAR driver paper, how he ranks them, if you read the beginning of the intro, the motivation is very economical. He's like, hey, look, NASCAR's making tons of money, so it's really cool to get into the statistics. So I figured, well, gaming's making lots of money, so I could motivate my paper that way. And I did. I got at least one published that way, so it kind of works. But I decided to finish my PhD in matchmaking instead. And so I've got a bunch of papers in my PhD on neural networks, and then suddenly there's a couple of papers on matchmaking and ranking players and things like that. Then I made us think about it. I think this is probably one of the most important things you guys can get out of this slide here, is when you do something you think is cool, you should make us think about it. In the academic circle, usually you try to publish in the best paper, best journal you can, and get your peers and colleagues reading about it. And I did some of that. And I also started emailing people in the game world. And there were some people that were kind of doing both, that were both in the game world and publishing about ranking players. And I, of course, emailed them. I said, hey, look what I did. And what that got me is it got people to know that there's a guy out at BYU who's doing ranking and matchmaking stuff. So you guys, if you come up with something cool, you try to publish it, you can make a game, try to post about as many forums, and by forum I don't mean like online forums, but just the general sense. Wherever is applicable, get it out there, and people will find you. If you do your very best, do a great job, you put a lot of hard work into it, usually people will eventually come and find you, which is kind of what happened, it was funny because as a kid, I had a mentor when I was a teenager. He was, he had a PhD in like civil or environmental geoscientific engineering from Berkeley, and had his own firm doing a lot of really cool stuff with trash dumps mostly. But he told me, just go get a PhD and people will find you. Don't worry about it. It's like, how am I going to get a job? I didn't really believe him, and then it happened, and now I believe him. So yeah, Blizzard found me. I got an email from them. They had talked to. I actually at one point interviewed at Microsoft Research in Cambridge in England. I talked to those guys, and they had written a paper in Game Developer magazine, which I kind of gave them a few pointers, not pointers, just some input on that pointers. They knew what they were doing, and they put me in the acknowledgement. So the Blizzard had contacted those guys at Microsoft and said, hey, do you guys know anybody who'd be good for doing matchmaking? And then they referred me along. So I'm kind of grateful to those guys for that. So the point is, do what you love, and then make sure when you come up with something cool, don't be afraid to tell random people about it that you think would never email you back, because they probably will email you back if you do a good job. Or even if you don't do a good job, they'll see that you're in their area and they might want to hire you anyway. Okay, so which happens at Blizzard, by the way. I don't know if Rob Pardo mentioned this last time, but he hired somebody who gave him this like 26-page argument about what he thought was wrong with one of our games. And Rob looked at it and said, you're totally wrong, but your passion's awesome, so he hired him. So just to know that, don't be afraid to talk and tell people what you think. So let's talk about Wolfenstein Enemy Territory. Mr. Bean's not really in it, but this picture was fun. So it's a team-based, objective-based first-person shooter. So you've got axes, and you've got versus allies usually. One team is usually defending an objective, another team is trying to destroy or steal or grab or whatever, some objective in the game. So these are asymmetric maps, so it often is easier for one team to win. Usually the team that is going after the objective, actually, it's usually easier for them. And so that comes into play in the matchmaking, and I'll talk about that a little later, but it's important to understand that if you make the better team the defending team, then the map goes forever pretty much, and goes a really long time, and it's not as fun. Enemy territory, the way you play it is on a dedicated server. Does anybody not know what a dedicated server is, or who knows what one is? Basically, you run an enemy territory server, which for us was just a Linux app. App's too small a word for it, but anyway. So it's a server, and when you want to find a game to play, you go to a server browser. You load up enemy territory, and it gives you this big long list of the thousands of current enemy territory servers out there, and you try somehow to pick which one might be best for you. And it's kind of random. Usually, I think most people sort by ping and then pick the one that has a lot of players on it. That's a pretty common way. Nice thing about enemy territories is it's free. I don't know the true story behind this. I just know the anecdotal story that Splash Damage was making enemy territory as an add-on for Return to Castle Wolfenstein, which had similar multiplayer. They finished the multiplayer pretty much, and they were moving on to single player, and it was just going to be a lot of work. And the Quake 3 engine was kind of showing its age at that point, and Activision just said just release it for free, and you don't even need Return to Castle Wolfenstein. So, as students, if you like first-person shooters, then I think it's a great one to check out. It's really fun to play with friends. I actually didn't mention up here, it's class-based too. So the maps actually usually require you play a certain class in order to get the objectives done. If you don't have someone on your team of that class, you can't do it. Which some people hate, some people like. I thought it was fun. Yeah, so like I said, usually you get dedicated server lists, or you get some big list, you sort it, you filter it. The nice thing about this is once you find a good one, you end up with these like communities springing up around these servers. You get communities start their own forums, people come into the forums, and you get a community of a few thousand people coming and going. And that's what we had when I was back in the day with enemy territory. We had this fun community. And it was also great because there were people I could experiment on with my game design stuff, and they were sometimes patient about it. So you had a lot of great communities. The bad thing about dedicated servers is that's putting a lot of work on the player to find a match. When a player buys a game, they usually want to jump right in and have some fun playing it. They probably don't want to have to go through a list and somehow figure out what could be a good server to play on. So it's a lot of extra work for the player. So I started working on this mod because there are features I wanted on our server that this mod, some of it had some of them, and there are features it didn't have, but I figured I can work with this guy as an open source mod and I could add them and that'd be great. But I want to just iterate that, rapidly iterate, how important it is for you guys, if you want to get into the game world, to start developing games, like right now or whenever you can. So I learned a lot about game development and game design by working on this mod. Even simple things like how to use a source control system to control the source code and to keep track of it. And it's really awesome on a mod because I could make major changes to the game and then deploy them to my servers and then get instant player reaction and then fix the problem usually, because if you make a change and players would hate it. And then you ratchet back or whatever. But it's a really awesome way to learn game design. The best way usually to learn game design is to do it. And if you've worked on a mod before and you go to get a job, you're not going to get a game design job these days usually unless you've done game design. And especially with so many tools available. I mean, I'm biased towards mentioning, of course, the Starcraft 2 editor, but if you grab these tools that are freely available, a lot of Starcraft 2 editors are not free right now, but there's a lot of freely available tools you can grab and make games with right now. So if that's your desire to get into the game development world, it's really good for you to start doing it now. You learn what's fun quickly, you learn how to polish, you learn your audience and what they like and how to design for them. So this is probably what got me my job more than almost everything else I did. Pardo was the guy who was looking for somebody, and the other people he had interviewed, a lot of them had pretty good, strong math backgrounds, but they had no design background. And so they were kind of erring on the side of just do what the math says, whereas I would concede to Brock that sometimes what the math says is not going to be as fun and we can find ways around it. So again, I wanted to rank my friends now on the server. And of course my friends are the best, so I had to make sure I rank them the highest. So how do I do this? So what do you guys think? How do you rank people in first-person shooters?
Kill-death ratio.
Kill-death ratio? Kills, right? Okay. What if during the day you got a lot of noobs on? And so during the day, I decided to play during the day because I'm better than most noobs, and so I have a really high kill-death ratio. I avoid playing at night because I know that's when all the good players come out. And then I'm ranked number 1. That's what I saw. My friends weren't number 1. I knew it was wrong. But yes, so I definitely did kill per death ratio kind of stuff. Objectives. Enemy Terror is an objective-based game. So I could assign points to when people did things. You planted some dynamite, that's worth something. Oh, you defused dynamite, you saved the team, that's worth a lot. He resuscitated someone who had been knocked down, so that's really helpful because then that guy can get back up without having to go back to the spawn. So that actually worked pretty good for a while. And enemy territory actually has built-in XP tracking, which also is kind of helpful because I can use that XP as a measure of how good these players are, because if they're earning XP quickly, they're probably good players. But whenever, in my experience, you use stuff like that, one, you've got that problem I mentioned of the noobs play during the day, so you can just play with the noobs and inflate your rank. And the other problem is it's exploitable. I would see these strange occurrences where engineers on two opposing teams would, I'll plant the dynamite, get some points, and you come over and defuse the dynamite. Or I'll blow up the command center, you come in and rebuild it, and then we can get lots of XP very quickly that way. So really, yeah, so then you come up with something, well, maybe I'll just combine wins and kills because those aren't exploitable like objectives and XP. But again, like I said, then you just play when the noobs are around and you might be okay. And we have people like that. We have good players that would do that because they knew I'm pretty good, but just as long as I avoid Josh's friends at night, I'll be in good shape. And that's exactly what they did. They really avoided my friends. It was kind of sad. Some of my friends did actually was they pretended to make a girl clan and called themselves girls. And I'm not trying to insult girls anywhere. I don't know why they did this. But they called themselves the Powerpuff Girls. And they named themselves after the Powerpuff Girls. And then they challenged those guys who were calling themselves the best players on the server, and they beat them really bad. So it was good, though. It was good. So during this time, I stumbled on some work done by Arpad Elo. And anyone are familiar with Elo rating and Elo ranking? So some of you are. He was, I think, Hungarian. So he wanted to rank chess players, and so he came up with a way to rank chess players. You see, I talked about it. So again, yeah, you're putting a number on team skill. You can call player skill or team skill. And then you're assuming that the difference between skills has a distribution. And I think Arpad originally used a normal distribution. Chess switched to logistic. And when you integrate over that difference between two players, you can get a win over that distribution. You can get the win probability. And it's common to use a logistic cumulative distribution function. Now I might be using a lot of math words now, but Hal knows I'm mostly hand-wavy stuff. But the nice thing about logistic is as a closed form, whereas the normal distributions, cumulative distribution function doesn't have a closed form, but you can find it in numerical recipes and stuff. Anyway, but back then, you didn't have numerical recipes, I guess, or as much computational power. But the problem with ELO is it's a little slow. I don't know how familiar you guys are with it. It has this thing called a K-value. And the K-value basically says at the end of a match, I'm going to update these numbers that tell me what I believe about how good these players are. And it's usually just some people will change the K over time a little bit, but usually kind of pick one K and stick with that K-value. And that K-value tells you kind of how fast you can find how good they are, but you want it to start off kind of fast when you don't know anything about them and then slow down. But and some chess ranking systems do that, actually. They have a built-in way to do it. It'd be nice if you could have that work automatically. But the problem with it is that, it's at least in practice, it seems to be relatively slower. And slow can be bad because if you've got, say, a game like Warcraft 3 where day one you've got hundreds of thousands, millions of players jump in and want to play, if it takes too many games to figure out how good those players are, the bad players are playing good players for too long. And if that happens, the bad players stop playing. And the more that happens, less smaller audiences mean worse matchmaking because there's less people to choose from, there's less likely to find a bad player. And then over time, that matchmaking queue, where people are matchmaking play, gets smaller and smaller because it's just too hard. Other things that ELO doesn't naturally handle, but you can adapt it to, is what about group versus group? So in enemy territory, you have 16 on 16 players, and these aren't static teams either. It's not like you just pick a team of 16 and it stays that way. You can't track it as a single unit. You've got players coming and going and moving around a lot. So how do you handle the fact that you've got group versus group when you want individual player rankings, not group rankings? And also, should you matchmake a brand new player differently than your experienced players? if you know, when you have a player that's been in the system for a while, you should be able to say something about how confident you are in his skill, how well you know his skill. Whereas a new player, you don't know anything about it. And ideally, you want to match these players you don't know anything about with players you do. Now, I say that with the caveat that if your goal is actually to solve the system and find out how good everybody is, you don't want to do that. You actually want to find the match you know the least about, because that gives you the most amount of variance, most amount of uncertainty, and you want to ask that question. But if your goal is to have happy players, so here's another case where math isn't always, the goal of finding out their skills doesn't always agree with what's a good match. If a brand new player comes in, it's probably bad. The good thing to do is probably to matchmake him against known bad players rather than players right in the middle or unknown but probably bad players, things like that. So how do you do all that? With Elo, it's not, you can kind of engineer that and hard code it and come up with a system to do it. I'll talk about how we did it instead a little bit. I won't go into too much details because the math gets probably beyond what we should talk about right now. For those that are curious, another way, I had to plug my paper here. Another way to look at this, at matchmaking and rating players is actually logistic or probit regression. Anyone here familiar with logistic regression? No? Oh, well, one over there. Probit regression and logistic regression solve similar problems, but yeah, none of you are familiar with that. Familiar with it might not be that easy to explain. It's, yeah, I won't go too much on that. You can come back to me about it later. Or you can also, there's ways to cast the same exact problem as an artificial neural network. Just different ways of moving the math around and you get the same problem. And I wrote a paper on that. And you could also think it's just classification. So if any of you have done any machine learning yet or know what classification is, then you may or may not, it's another form of it. So it'd be nice to measure, like I talked about, if we've got some new guy in the system, it'd be nice to tell how good that guy is. And not only for a new person to come to the system, it'd be nice to be able to tell our system we don't know much about this guy. And it'd be nice if we can tell that the people we do know about, you know, how much we know about them, and that those values should change appropriately over time. So one way to do this is assume that not only the difference in skills has some kind of distribution, but also the skills themselves. And one common way to do this these days is to assume that player skill follows a bell curve or a normal distribution. So you assume that a player's skill looks kind of like this, and he's got some, you know, some center, some mean there, and then he's got some width. And then so as we get to know our players, this would shrink until we're pretty sure where that player skill is to some degree. And the nice thing about this also is I talked about that K value for Elo, and I'm kind of hand waving on the math. This dynamically kind of gives you one way to dynamically pick that K value and make it almost as fast as you can make it, you know, based on your assumptions. But again, I'm kind of hand waving about that for now. You can ask me about it if you want to. There are methods that do this. Glyco is one by Mark Glickman, and then there's TrueSkill, which is the guys at Microsoft Research Cambridge did, and it's also on the Xbox 360. If you do most of the matchmaking on that, I think it uses TrueSkill. A lot of it does. And the nice thing about this is now if we assume that players, the skill that they have is this kind of bell curve, normal distribution, Gaussian distribution, some people call it. If you now want to rank individuals in groups, one model you could use is just assume, okay, well, if I've got a team of 5 people, I know their individual ratings, I can just sum up that rating and get a new rating, and that can be the rating of that group. And since it's normal distribution, if you sum up normal distributions, you just get a new normal distribution. It just has the, and I don't know if it's math. Anyway, the mean is going to be just the sum of all those other player means, and the variance is going to be the sum of that variance. And then you can just use the same exact math that you used for Glyco or TrueSkill that you used before. Okay, so again, I keep saying you need it when you rank players in these games. It needs to be as fast as you can. Otherwise, your hardcore players are going to outpace your kind of newer players, and then you're going to shrink with your queues are going to shrink, which I think kind of happened in Warcraft 3, definitely today. I mean, this happens to all games eventually. The amount of people playing a certain format goes down. The method that we use is called Gaussian density filtering. That's one thing to call it, I guess. The latest paper in that came out last year, and as far as I know, it's the fastest way to fit the rankings and fit these models in literature. The model itself is actually kind of old. I think it dates back to 20s or 30s. Some guy named Thurston and most other psychologists, I think. But But how you fit them is the interesting problem from a computer science point of view. Is I've got millions of players now. I need to fit these models quickly. I can't store all the data about every single match forever. When the amount of time I have to update what I believe about a player is usually just within the end of that match to the next match, which is seconds. So Gaussian density filtering is fast, both in the sense that I can do the update quickly, and that it converges quickly to the skills of the players. So, anyways, I like it. It seems in practice to be very quick. It works really well. But then you got to ask yourself for your game, where do I put this rating? Do I put a rating on every player? Do I put a rating on every team? Do I put a rating on every party? Because in, say, Starcraft 2, I can get together with a friend, me and him, and then we can queue for 3v3. So just me and one other person, party of 2, can go play 3v3. And then it's going to go find a third guy for me to play with. So do I put a rating on that little group of 2? How often am I going to be with that team? Does it make sense? So when you're rating players, you got to ask yourself where to put those. It's usually more efficient to put them in the largest groups you can. I won't go through the map a whole lot, but the larger, so the larger the group you can put them in, these teams in, and carry that group around, the faster you can figure out how good they are. So if you've got something like 40 versus 40 where you want to find every individual's rating, a single match gives you like 1 bit of information. You got to share that 1 bit of information across 80 people. So it's going to take a lot of those matches to tease out how good all the players are. Whereas if you know those 40 players are always in that same team, you can treat that as just one unit. Now you're back to 1v1, which is very quick. So things to think about when you're rating players. In StarCraft 2, every team that's the size of the queue that you're queuing in. So for 3v3, if you make a team of 3, that has its own rating that sticks with it forever, as if it's just a single team unit. If you queue for 3v3 with less than a party that size, you get an individual rating on you. So anyway, Gaussian density filtering is fast. Skill and difference in skills is normal. Again, the cumulative density function, which you guys might not know much about, is no closed form, but it's in libraries. It's been faster in practice for me than ELO or Glicko, and that basic idea is at the end of a match, I take a step towards where the evidence in that match tells me the mean of that player's skill is. So now let's go back and rewind a little bit to enemy territory. So what did I do there? So in enemy territory, it's not like if you guys, any of you played StarCraft 2. Anyone who played StarCraft 2 or used the matchmaking in StarCraft 2, said find me a match? So you know on that one, you just get together with as many friends as it allows, or just yourself, and say, find me a match. Well, again, enemy territory is a dedicated server, and so you've got like 32 people, and they're switching teams, they're coming and they're going, and it's not like anyone says, find me a match. They're just sitting on a server, which is interesting. So what would happen before we had any team bouncing is people come to our server, the server worked pretty well, they play, they'd have fun, and then they'd make friends, and then they'd want to play with their friends, and they would end up being really good when they played with their friends. And so you'd get groups of players constantly playing with each other on the same team. When that happens, that team ends up winning a lot. So it's not that fun. I'd come in and check on the server, and this one team had been winning the last 5-10 games, and it's less and less fun. So so let's assume I have numbers on these and know what their skills are. What can I do to improve the experience for the players? Well, there's a few things. There's in-match shuffling. I can make a command where I hit this command, and all of a sudden it just shuffles the players so that the teams are even. And the kind of way I did this greedily was take the best player, put him over here, take the second best player, put him over here, then take the next best player and put him on whichever team makes it the most even, and just keep doing that. That works pretty well. But it's not that fun if you're playing a game and then it suddenly shuffles and you're no longer an Axis, now you're an ally, and you're going after a completely different objective. It's not that you could do this where I only make one movement every now and then, just try to move one player, but even that's kind of annoying. So, so here's a fun point before I get farther into that. I thought it was fun at least. So when I first wrote code to do this for enemy territory, I didn't tell it to make sure the team stayed even. I just had to make sure the skill is even. So what ended up happening was if there's a really, really good player on one team, it would start moving players off that team because that team was just too good. And so you'd end up with like 3 dudes that were really good on one team and then like 25 on the other team. And then the matchmaker's like, nope, this is even. This will be a great match. And yeah, it kind of was right. In those situations, that team of 3 still won about half the time. But that's not very fun, I don't think, because now you've got 3 dudes who've got plenty of people to shoot at, but it's just too crazy. And then you've got 28 or 25 people running around looking for just 3 people who are like really, really good. So when they find them, they just die. So yeah, that was right mathematically, but not fun. Yeah, another example of that fun stuff. But yeah, what about the problem when players are coming and going, switching sides? You kind of want to approximate sort of the integral, the skill at every given time. And so it's kind of, if you just prorate how long, what percentage of the match each player played on each team, you end up with something that kind of does that. Again, maps might be asymmetrical, so you want to rate the maps. You find out that this map, all else being equal, allies are going to win 60% of the time, even if there's equal teams, because the map favors the allies. So when you're matchmaking, if you want, depends what your goal is. Maybe you want that to stay the same, in which case just ignore the map balance. But if you want it to actually be an even match and give the Axis a chance of winning, then you should take that imbalance into account. And the map, you can do that in the map pretty naturally. It also helps level design. If you're designing a level and you're having lots of people play while you're designing it, and you can use the same type of math to find imbalances in your level. Find out that, yeah, even with even teams, this map is biased towards the Axis. So I want to fix that rather than enforce that kind of matchmaking. We actually do that in Starcraft 2. We do use the same, very similar type of map to tell, hey, if I compare Protoss against the Terran, is that an even matchup when the teams are about equal skill, or is it not? And we have a lot of data, so we have plenty of matches where it was or wasn't even skill, so we can kind of get that out. But we also want to know, on this map, does it favor Protoss versus Terran? And we don't use that in the matchmaking because it's the level designer's job to make sure that's not an issue. But I can tell the level designers, hey, your level's a little imbalanced. And they can look at why, try to figure that out. So what I found for enemy territory, though, is a good way to matchmake is to kind of let the players choose their team. It kind of gives them a sense of control. You jump on a server and you say, I want to join allies. And then you have it tell you if that's a good idea or not. You say, sorry, you can't close allies, you're too good. Or you can't join allies, you're too bad. But that might not be the way to say it. But basically tell them, if you join this team, it's going to be becoming uneven. So then you manually join the other team, but at least you feel like you're doing it. We're not just moving you around. And again, this isn't very fun. Something else I did for fun, because again, if you study the math behind this, you realize you can generally try to examine almost anything you want. There's problems with doing that I won't get into, but so I looked at, okay, now I know the map's in balance. I can tell if the players are balanced. Well, let's look at how time affects the balance of this map. So, for example, if this map is going for more than 20 minutes, that's some evidence that the defending team says the Axis is a little too good. And so it's kind of interesting what it did is there was this one map that the Allies would always win pretty quickly on. And if they didn't win quick, then it was because the Axis team was way too good. So I think what it did was it wouldn't let anyone join the Allies for a while. It's like if I let them join the Allies, they're going to win because this map, people always win fast on it. And so what that said against another map balance thing, it told me that the time limit was too long for that map. So I shortened the time limit to about where it was allowing people to join the team. The matchmaker was saying, I can't put them on the Allies, they're just going to win. I'll wait until it looks more like the Axis had the chance. And as you make the map, if you find that length of time in which the Allies, given even teams, would win, so if the map's 30 minutes long and even in even teams, Allies will always win within 10 minutes, then make your map more like 10 minutes long so that it's up to that wire when they have to win by. So anyway, you can use that to balance maps. So now rewinding a little bit now. So I talked about the one common way, early way of finding matches is you have this big dedicated server list. Another way, which if any of you played Brood War? Okay. So in Brood War, you go into a chat channel, and you go into different themed chat channels, and you try to convince people to play against you. And then once you convince them to play against you, it updates an elo values. This was kind of exploitable because if you can choose your opponents, and also you can make as many accounts as you want, you can. If you're smart enough, you can probably make your elo almost whatever you want. So that's why you kind of need I want to say random matchmaking, in that it finds an opponent for you that you can't choose. But yeah. The nice thing about channels and rooms is that you kind of have this community again. And community can build up around a room or a channel. But again, you get that overhead. In Brood War, you have to go find someone, convince them to play against you, which is a lot to do. At least in a dedicated server, you can jump on the server and there's people playing. In Brood War, you got to kind of do this whole social engineering thing to convince this noob to play you so you can beat him. Which, yeah. And it's a little bit less controlled though than a dedicated server. Dedicated server, you feel like the server, whoever's setting up the server can set whatever he wants. But just kind of showing you kind of evolution in my experience. And now we hit quick play, which I've talked about, where it's streamlined. I just want to say, hey, let's just go find me a match right away. I want to play, and which is what Warcraft 3 did. That you kind of lose the community feel, I think, somewhat, because we're not forcing you into these dedicated servers, into these rooms where you have to talk to people. I don't have to talk to anyone anymore. I can just jump right in. It's really great though that you can just get right into the game. As just a note, it's a lot harder to implement this than because now you've got to do the matchmaking, and you've got matchmaking is not just the skill component. It's I've got a big queue of people coming into my server. How do I segment that and do it in enough time that the queue doesn't grow forever, and I can never actually matchmake anybody, and you got to deal with bandwidth and just a lot of other issues that come up. They have Warcraft 3 again, had ELO, like I said, which is I think slow. Maybe I'm being too mean to ELO, and yeah, harder to do that. So now I'm going to go on to say what I did with WoW Arenas a little bit. WoW Arenas is quick play. You make your team and you say, find me a match. When I came to Blizzard, there were some problems that they kind of wanted to fix in WoW Arenas. First, they wanted you to have a new rating every season, so that you can kind of feel like I'm starting all over again. I'm going to progress up to my rank and everything, and it'll be great. But the problem with that is that means at the beginning of every season, the matchmaking is terrible. Because now all the good players are just going to win like 10, 20, 30, 50 games in a row. They also wanted, when you change teams, they wanted it to reset your rating also, because they wanted rating to be the reason why you don't want to change teams. Because I built up this rating, I don't want to lose that by changing teams. It makes teams more important. And if you play WoW Arenas, you actually name your team, for better or for worse, got interesting names in those teams. And they wanted also just better, faster matchmaking. But Tom Chilton said he really wanted to keep that RPG progression. So there's a problem with the actual problem again, talking about a perfect matchmaking system would find your rating super quick. But in a role-playing game, players want to kind of feel like they're progressing up to their skill. At least that's how the system had been designed up to that point. And I was kind of revamping, not totally redesigning their system. So he wanted to keep that progression of I play some games and work my way up to my actual where I'm going to be. But Gaussian density filtering gets you there a little too fast from what I showed. Actually, way, way faster than our data was showing that these players were arriving at there using ELO, which is what they had before. So I found a way around this, do a lot of experimenting, simulation, stuff like that. Simulating is a great way to also figure out a system for design or engineering. So now I figured the solution I came upon was I'm going to need 2 ratings. So if any of you are familiar with about January of 2009, this is pretty interesting. When I released this, it was a little confusing at first. So this surfaced. And I didn't add the next part of this, which is a picture of somebody winning but actually losing points. That picture was not from when I released this. It was actually a glitch from before, nothing to do with it, but it looked funny. So that was the joke that, yes, Menke put a rating on our rating, so now we can lose even when we win. It's great, which is not what happened. So basically, I needed to separate the matchmaking rating from the progression rating, but they still wanted the progression to feel like ELO. Well, the nice thing is, Gaussian density filtering ELO, the numbers that come out of those historically are different. ELO is on used a different scale, but you can convert between them. So all I had to do was take the rating I was getting out of my matchmaking system and scale it to look like a rating in my ELO system, and then pretend that there was the same, they do the same exact type of update I would do before with the ELO system. It's a little complicated. You don't have to get it right now, but basically what happens is the ELO kind of trails the Gaussian density filter rating. So I can have fast matchmaking, but still have some progression. And then we could actually, using that K value, we could tweak just how fast we wanted players to get to their ratings and do a couple other tricks. So it gave the designers some nice control over the dynamics of the progression system by kind of doing this bit of separation between the matchmaking and the progression rate that we were showing players. And yeah, so like, how do you do this? Because if you just implement this naively, just as a thought exercise for you guys, so I've got ELO here and I've got Gaussian density filter. Just assume that the matchmaking rating gets to the right rating really fast. So now you're within a few games you're going 50-50. If you're already going 50-50, even if you're say a 2200 rated player, and then I plot this much slower ELO system to trail that, if I just use the ELO by itself and just ignore the interaction between the matchmaking rating and the ELO rating, if you're going 50-50 in the ELO system, you're going up and down the same amount every game in your rating. You're going 12 points up and 12 points down, 12 points up, 12 points down, and you don't go anywhere. So you might be 2200, but unless you look at the interaction between these two, the system just doesn't work. So anyway, that's what took some math to figure out, but it wasn't too bad. And if anyone's really curious about it, or a glutton for mathematical punishment, I can show you how I did it. So Starcraft 2 actually used the same math as we used in World of Warcraft. It's a little bit different. We have a matchmaking rating. We do have an ELO rating. We actually added a placement rating, which is kind of a hack, but it's this thing where so in StarCraft 2, we wanted you to not, so now it's okay to identify yourself by this number that increases over time. So in RPG, players kind of understand that. In StarCraft 2, we wanted you to not say, hey, I'm a 1480 player. We wanted you to have more broad definitions. We wanted you to say, hey, I'm a gold player, I'm a silver player. We thought that would be a little more understandable to the average person. And maybe it is, maybe it's not, I don't know. People are actually getting pretty familiar with ELO these days. But it kind of works, in my experience these days, players get super excited when they get promoted from bronze into silver because it means something and it's hard to do. We were going for this more kind of city league feel, but I'll talk about that later. So yeah, we used ELO again. So I had this kind of placement rating because we're like, when do we move you from bronze into silver? Because rating is kind of noisy. It still fluctuates within kind of the variance within its uncertainty. So you could be bouncing between silver and gold, say, a bunch, and we're not sure, well, are you going to stay in gold? Should I promote you right when you get up there, or are you going to bounce back down? So we have this kind of hack, which is you call it leaky bucket filter, exponential moving average, where the placement rating is sort of a smooth average of your rating over time. And so when that smooth average, if you actually belong up in gold, you're going to smooth out above gold, and that's when we promote you. We actually promote you when those two get close to each other, to make sure. Anyway. So, and so then we wanted the City League thing in StarCraft 2, where we want to put you in this group of just 100 people because we figured that's about what you can get your head around. You can probably get your head around 100 people, where if you're just, Warcraft 3 was 1,000 people, and so you got pages and pages of people to look through to find your rank. We figured that if we just give you 100 people, and then let's see, do I have it in here? So is anyone familiar with the bonus pool system? So I'm getting more into design here. So in StarCraft, in Warcraft 3, if you stopped playing for a while, we actually decayed your rating. We took points away from you because we were saying, you're not playing, we want you to drop in rank. But one thing we like to do at Blizzard, and I think Rob might have mentioned this, is we want to make it a bonus. So instead of decaying your rank if you don't play, we just give everybody else points. So if you keep playing, you get this kind of constant stream of extra points. It's a constant amount for everybody, so it doesn't actually inflate the ratings at all. But if you haven't played, you haven't spent your bonus pool, you haven't earned these extra points that were given to everybody else, and so you fall behind. Which means if you come and play at any given time, the system's designed, if you jump in, we've got this group of 100 people, just by playing at any given time, you're probably going to jump up several ranks because they haven't played as recently as you. So that's kind of how we wanted the system to feel. I jump in, I play, and I'll earn a few ranks just by playing. And then for the most part, that works pretty well. You eventually will hit a wall in any ranking system I've seen so far, and it's hard to remove that wall without removing the skill-based nature of it, but that's some philosophy I don't need to get into right now. Okay, so yeah, Blizzard matchmaking in most of our games, again, it's like that quick play style. So basically, you've got a big pool of teams. Some of them are partial teams. You want to arrange them into some kind of puzzle to get the best 3v3, 4v4 teams out of these 100 people that all come in to find a match. I think this is empty complete. I might be just hand waving on that. And so you want to ask, okay, can we just use greedy? Can I just sort them on their rating or sort them on the difference in ratings and then pick the best matches? And it works almost perfectly for 1v1, unless you have an odd amount, because then you get this kind of, don't want to shift it up or down, but that's all. But when you get into 2v2 and then 4v4 and then 25 on 25, and you've got some people in groups, some people not in groups, what we actually end up using in StarCraft 2 is a global optimizer. So we kind of have this utility function, and I won't go into too much detail, but we try lots of different combinations, and when we find better ones, we kind of stick with that one and keep trying until we kind of randomly bubble our way up to the top, hopefully, and that works pretty good. And the nice thing about that is it naturally takes care of all those people in groups, and we could throw other things in there if we wanted, like ping or anyways. So yeah, so talk a little bit about matchmaking design, because you might just think, oh, matchmaking, you just find the rating as best you can and make the tightest matches, and that's kind of true. You definitely want to start, I think, getting as tight as possible, at least at first for your debugging, and then after that, consider if you want to change things. I think an important part of the design here, though, is to understand if players are going to get a bad match, how do they know they're going to get a bad match? How do you communicate that to them? And in StarCraft 2, just practical reasons and engineering, it was pretty hard to get feedback out of our matchmaking system to the players, let them know kind of how good the group of players that are wanting to play are. So if you play StarCraft 2, you notice they'll start waiting and they'll say, okay, we're waiting, and then they'll say expanding search. Well, I think it just waits a certain amount of seconds and just says expanding search. But it is expanding, but it's not like it's giving any information out. So what we did instead is we tuned the matchmaking. So the rating system works pretty well in StarCraft 2. It's pretty good at predicting the probability of players winning. And by predicting probability, I mean, if I say you're going to win 60% of the time, I don't mean you win every match. I mean, if I look at all the times I said you were going to win, you had a 60% chance of winning, you should probably have won about 60% of them. So yeah, that's one way to kind of measure if your system's calibrated right or whatever. But in our experience, what you want to do, though, is you want to pick something like, so what I want to do is I want to say if a player is going to feel the imbalance of the match when he starts playing, he better have felt the extra wait time. So we tune the wait so that once you go past about a minute, maybe 2 minutes, you know that that match is going to be harder or easier. Or you could put that in reverse. If the match is going to be hard, you better have waited. And so that's kind of how we tuned it. We made sure that if you got a fast match, for sure it was going to be a very close match. And if you're waiting a long time. And we chose 3-to-1 odds kind of as our point, where it's kind of when you can tell the player's better than you if he's got a 75% chance of beating you. So other things to think about if you're doing matchmaking. Really, it's best to give as much feedback to the players as you can while they're waiting. I think Rob mentioned that when he spoke on this. Just let them know what's going on if you can. So if you guys ever go club a matchmaking system, come up with some way to let them know. You gotta be careful though, because you want to tell them I'm getting really close to matchmaking you against a really hard person, because then they'll quit out, and then you don't want that. So you gotta balance that. Okay. So this whole discussion, it's been kind of biographical, but I've been trying to kind of show you along the way sort of how I got into gaming, which is important, how I learned about gaming by being in gaming and trying things out, and some elements of both matchmaking and ladder design. So I'm hoping that hopefully you picked up on some of this as I've gone along. But here's kind of some of what I've learned here. So when you're designing a ladder for people to play on, it's best if you lean towards fun and not mathy. I mean, some players like mathy and they make a game out of it, but for the most part, you want it to be as understandable as you can. In StarCraft 2, the way we kind of tried to help with this is, so have you guys noticed on the load screen, it tells you something about the odds? They'll say like slightly favored, favored, even. All that is the math behind the scenes saying, okay, if he wins, how many points is he getting? Regardless of what the actual odds are. Because you remember, StarCraft 2 has 2 ratings going on. It has the ELO one that's kind of what you see, and it has this faster one, which is how good you really are. And at the first part of a season, the one that you see is not as accurate. So the number of points it's telling you that you're going to get at the end of that match, it's not always proportional to the true odds. So when you see even, all that means is you're getting somewhere between 11 and 13 points. And and out from there. So all those messages are about how many points you're getting, because we thought, well, players will get used to understanding that directly translates to points. And then on the score screen, you see the same thing. You see, oh, I got 13 points. Okay, it was an even match. It was 10 to 12 points. 13 would be your opponent was slightly favored. So you understand right away that, oh, I get more points when they're favored, and when they're favored, I get less points when I'm favored. That's how this whole system works, because lots of the players coming into the system have no experience with ELO type systems. So it's nice to kind of educate them that, hey, your opponent was easier, so you're not getting as many points. They get used to that. They kind of understand. Then they start to figure out in their head, oh, my rank and my points in the system actually are proportional. Have take into account who I played, not just my win percentage. And so some of you might know we took out losses. Part of the reason we took out losses is because for most players in the system, looking at your win-loss ratio is meaningless because it kind of goes towards 50-50. So it's actually, it can be, I guess, depressing, but your win-loss ratio, all that really tells you is the difficulty, kind of tells you a little bit about the difficulty of your opponents or if the matchmaking was good, but it really has nothing to do with your skill in systems that are hard match-made like this. Unless you're at the very top or very bottom. Something else to think about when you're designing ladders is how do players rank up? How do I move from gold into from gold to platinum? How do I get higher in my rank, my division? It's pretty easy to see how you get higher in your division. You spend your bonus pool and you beat players that are better than you, or you just win. We haven't released a lot of information about how you rank up from in the league sense. We'd hope that players would focus more on the divisions, but that might have been a naive hope because obviously when the leagues tell you the most about your skill, players are going to focus on leagues and want to know how do I get promoted to another league. And a lot of times people won't get promoted to another league. When you play Starcraft 2, players will start playing, they'll learn a lot, and then they'll kind of plateau, and that's how good they are unless they put some serious time and effort into studying the game. And even then they're going to eventually hit a plateau, and they just won't get, will never be promoted into Master League or into Diamond League. And that's kind of where we got into the system, is this idea of, we don't want players to focus too much on league promotion, because once we find out how good they are, that's not going to happen very often, so we want them to focus on just getting good ranks in their division, and then tournaments down the line, maybe someday, I don't know. So, but players really, really want to know how they rank up, and so I've tried some experiments with the community where I've released on the forums. Well, if you can hit this ladder score by the end of the season, then you will be promoted next season, almost for sure. And I can do that because even though the ladder score you see is not the behind-the-scenes, hopefully accurate skill rating, it converges to that. By the end of the season, they are pretty neck and neck. So that rating, it's got your bonus pool in there, but it's comparable. Other things to consider in ladder design. Is this an RPG? Is this an esport game? Is it somewhere in between? In some games, a pretty hardcore ranking system doesn't really apply. If you look at if you look at WoW, we do have that kind of hardcore system, but we also have the kind of reward systems that are on the side. With Starcraft, again, we were going with city leagues feelings. We're like, this is an esport. We want it to feel like a sport. In sports, you have leagues, and it kind of feels cool. And we felt that the ladder system kind of paralleled the kind of esport nature of the game. Starcraft 2 is a pretty, I guess, it's like a sport in the sense that it's all or nothing. It's all about the win. Then, you want to ask yourself questions about, do players feel like they're progressing or do they feel like they're stagnating? And does that matter for this game? In StarCraft 2, we try to tweak it a little bit so that most players feel like they're progressing until the end of the season. And they don't feel too much stagnation. And, so they can feel like it. And also be aware that people are going to find exploits and then be ready to handle them. So understand the math behind your systems well enough to be able to identify the exploit and think about how you can solve that. We've run into that a few times in World of Warcraft, not so much in StarCraft 2 because things are a little bit more straightforward, but in World of Warcraft there have been definitely some times where they're really edge case type things that are pretty easy to handle, but And just understand that giving people ranks and leagues motivates them, for better or for worse, to play differently. And think about that ahead of time. So how is this going to motivate the player to play if I give them points and rank in this way? So what if I gave you points, so as an extreme example, what if I gave you points for every unit you killed in the game, including friendly units? So that's going to motivate you to play in an odd way. That's an extreme example, but there's lots of, if you go back to the enemy territory cases, if I rank you based on planting and defusing dynamite, then people will collude and do stuff like that. So actually, I think that's about all I have, which is a little bit early. But I've got a lot of time for questions if you have any. And I can go into some more fun ranking anecdotes if we don't, maybe. Any questions? Yeah?
Do you take into account like a degree of win, like how good a win was or not?
One thing I've learned about StarCraft 2, so some games you can kind of do that. One thing I've learned about StarCraft 2 is it's like the game of exceptions. In StarCraft 2, almost any case like where you're trying to track that, there's too many cases where you're wrong. But it's possible to do that. I haven't done that in any game so far. The reason you would want to do stuff like that is if you're trying to, if you need to get to their, there's a few reasons. One is you need to get to their rank faster, much faster. Say in I probably don't better not talk about that. Yeah, so anyway, if you want to get to their ranks faster, you can use extra information in the game. Also, if you have something like 4v4 in Starcraft or 3v3 in Starcraft or Warcraft 3, it sometimes feels pretty bad if you really worked your heart out in that match but still lost because you had really bad teammates. And that's something we've been trying to address. We've tried to address a lot of ways to do it. We may arrive at something sometime in the future, but right now we don't. It's just, there's too many exceptions where it looks like he's winning, but then he brings out like Dark Templars, which are cloaked, and that team wins despite being behind the whole time because the other guys forgot to build detection. So you've got cloaked units that can't be seen by anyone on the other team. It's too late to counter that, and that team just wins. There's too many things like that in StarCraft to make for that to be fair enough, I guess. But it might be worth doing just because it's more fun. So that's something to consider. I'm sorry, I think this.
I think sometimes maybe most of at most of the time that simplest method performs much better than the complicated ones. Have you ever compared the different methods?
Oh yeah. I mean, my last 2 jobs with Blizzard. At Blizzard, my first several months at Blizzard were trying, and the several months at the job I had before that. So I was at a different game company actually called Hi-Res Studios. They made a game recently called Global Agenda. I worked on that for a little while before coming to Blizzard. But yeah, I tried out tons and tons of different methods to test which ones converge faster to the rank and have the best accuracy and the best precision at ranking people. And it's kind of interesting. So Gaussian density filtering is maybe a little bit more complicated, but it's not that complicated. It's still just a linear system where you assume everything's normally distributed. It's not like a neural network or a support vector machine, which I could use to do this, but that would get really complicated. And sometimes it may be better. But Gaussian density filtering is pretty fast. I tried both. The method I came up with, which was basically I took a hierarchical Bayesian model and then did what's called Newton Raphson with it, which I don't know if you've heard of, but it's just a pretty common way of doing a quick fit to a model, and it's using gradient descent. I tried variational Bayes, which you may have heard of, which is pretty popular before density, assumed density filtering came out. I tried ELO, I tried Clicko, and all these methods, it's kind of interesting because all the more state-of-the-art recent ones, they all have been kind of different assumptions. Gaussian density filtering, you're fitting the distribution at the mean. Clicko and like my own method I came up with, they fit it at the mode. But if you have a symmetrical distribution, those are kind of the same. Kind of a picture of that distribution again to make this so much clearer. So it turns out players do kind of look like that most of the time. So if you look at this, the mean is right here, but so is the mode. The mode being where the peak is. So it didn't make a lot of difference in terms of the quality of the results, whether I used Gaussian density filtering or my own method, or Clicko even. One thing I did, I at one point extended Clicko to work with groups. But what did seem in general, the Gaussian density filter did seem in general to get to the solution faster. So that kind of made it, kind of sold it for me. Yeah, it's not as, Gaussian density filter is not as simple, but it's still relatively simple.
Oh, can you explain more that how do you measure the performance of the
How do I measure the performance of the players?
Yeah.
So,
I mean, different performance of the ranking performance.
of the what? Oh,
ranking.
the ranking performance. There's a lot of ways. So one way pretty common is, again, it's a probabilistic model, so it tells me what's the probability of Team A beating Team B, and for every single match, over millions and millions of matches, it can tell me the probability of Team A winning in this one was 75%, 65%, 35%, all the way down. What I can do is I can plot on a graph what was the predicted probability of them winning, and then what was how often, when I say that probability, how often does that team win? So I gather all the times I said 80%. And it's usually a little bucket wider than that, like 79 to 81. Gather all those times in my data where I thought the probability of winning was between 79 and 81, and say how many times did that team actually win, that gives me a data point, which hopefully is close to 80%. Then you can plot that. If those, if it's aligned, then you know that your probabilities are right, your model's predicting correctly. And then you want to look at, how's your matchmaker working, which is a different problem. And to do that, you just look at what's kind of the average, kind of plot the histogram of the average, or histogram of the average. Plot the histogram of difference in skill between all of your matches. Let's see, you were next.
You said, or when you were talking about the bonus pool, doesn't that cause inflation though? And isn't that bad?
No, bonus pool is, the reason it doesn't cause inflation is because when I compare your score to the other team's score in order to update it, make it bigger or smaller, I ignore the bonus pool. So you could be 1,200 rated and have 300 bonus pool, and you beat somebody who is 1,200. I compare 1,200 to 1,200, not 1,500 to 1,200. So the bonus pool doesn't enter into the ratings updates at all. It depends what you mean by inflation. If by inflation you mean are the skills wrong? No. If by inflation you mean everybody's higher than their actual skill? Yes, but everybody's at the exact same constant amount. If you and I have the same exact skill and we play the same amount of time, and not even that, if we played recently, it doesn't matter how many games we played. If we played enough at a certain point in the season, our ranks will be exactly the same. Our bonus plus the the visible skill component are exactly the same. Everybody gets the same amount of bonus. Yeah.
I don't know if I'm sure you've heard of League of Legends.
Yeah.
I don't know exactly how to use, but from what I can tell, what they call it is like they say it's a ELO-like system. I have one thing to say and then a question. Like for one thing, they have streams. So there's one guy who I've seen who has like excessively high ELO. So he'll play a ranked game, then go screw around for 30 minutes, then come back to when the game is actually about to start. And that's what is that the kind of thing you mean by delay time? But then also, the real question is, what about playing that system? For instance, I've seen plenty of people that are like, they purposely lose to kill their ELO, and then they play really stupid strategies. Like I have friends who did that. They killed an account's ELO and then played really retarded strategies that stomped people.
Yeah, so that's this problem in any matchmaking system. Because the matchmaking system, it's going to give you an opponent. And if you can control the type of opponent it gives you, you can have a lot of fun. So that's definitely a problem in these systems. So I have a background also in fraud detection, because I worked at eBay. And eBay, my job was to kind of update their system so that they could catch people that were making bad postings on eBay and things like that. And we use a lot of kind of machine learning methods to do that. So my thought on that is if you want to get serious about catching people that play degenerate ways, you do kind of predictive analytics. You kind of come up with patterns that these people do. How long are these matches? Are these people playing in the same way, model the player? And then you can predict whether or not he is loss spotting, I guess you can call it.
Like for instance, purposely queue dodging is called. Like when in a ranked game, like you drops your ELO, and that's what they did. But
Yeah.
I don't remember.
Yeah, you can do, and you just want to detect that or do things to prevent that. In World of Warcraft, in arenas, you put some things in place where you don't play the same guy over and over again, so that became less of an issue, because you would, in WoW arenas, for a long time, and maybe still a little bit, often whether or not you win could be as much a function of the composition of your team in terms of the classes on your team, if any of you played WoW, whether you've got like, Paladin or Mage or warrior on your team, whatever the three of you are. So you jump in the queue, and you be near one of the better players, so there's not that many searching around your skill, and you play a team, and that team obviously counters you, and they beat you. So then you figure out some way to know if they're still on the server, which I won't talk too much about. But if you know that they're still on the server, you just don't queue, you wait till they're done. And sometimes you don't even have to worry about figuring it out, you just wait 5-10 minutes. So we put some stuff in WoW now where if you just play that team, it's not as likely to make you play them again, so you don't worry as much about that. But yeah, Tom Cabell actually posted on one of his forums a lot of details about the ELO system they use. And ELO's fine. It will converge to the same solution. It's just really slow. And I think the way he's using ELO to deal with groups and teams actually makes it a little bit less efficient. But I won't go too much into that.
One other quick question. More of a sort of thing. Does the person with the highest ranking on Starcraft who always play the same person who right below him?
No, actually, it was kind of interesting. There was a point where that was more likely. If they keep queuing together, it was more likely. So, and I did something interesting for better or for worse at Starcraft 2. The ratings were inflating. They were getting bigger than you really needed. So with a normal distribution, I can say, given a population size, what the maximum and minimum I expect to see in that population. You don't expect to see more than a certain number of standard deviations out. So I knew the size of my population for StarCraft 2, and I said, I don't need to have people have ratings above a certain value, at least the matchmaking rates. It's just not necessary. So what I did was I thresholded, kind of clipped their ratings, so that if you previously had a really high rating, it would clip it back to a certain number. And a lot of the top players are all at that number now. So when a top player queues, he can find matches a lot quicker. And that has caused actually deflation in the system, which I like. But it's not super common to play the same guy over and over again. It can happen, but it's not as common. Maybe you play in the middle of the night and then only one of you that are that good, it can happen, but it's not as bad as it might sound. And it turned out, at least even when I didn't have that on there, there usually were enough really good players around to not have to play the same guy over and over again. It did happen occasionally.
For StarCraft 2, do you look at different like race things where you'd have like your Terran versus a rating is different than your Zerg versus Protoss rating?
We don't do that in the matchmaking, and that could improve things a little bit. Some of the variances explain that way, but we do that in the. We have our own kind of analytics that we do. We talked about a couple of BlizzCons back where every time you play a match, I look at kind of the skill level of the match, kind of sort of in broad buckets like league buckets, and I look at who played who, and I have a completely separate rating system because I can't use the same rating from the matchmaking system because it's already biased by the matchmaking. So I have to start all over from the very first game and run it forward and look at who you played and the races. And we only do this for 1v1 because that's kind of where a lot of our balance is focused. We did a little bit of other litmus tests for the other 2v2, 3v3, 4v4. But so for that, we do have you actually end up you just put a rating on Protoss versus Terran. Just like you put a rating on the player, I can put a rating on PvT. And then I have a rating, like 1600 Protoss versus Terran or something like that. And that rating tells me how even or how uneven that matchup is, accounting for the skill of the players. So even if I had even players, which has been pretty useful. Again, it's not like the end-all be-all because that data is really noisy. So when we balance StarCraft 2, we use a lot of information, not just those rating numbers. What we can do with the ladder ratings, though, is the hidden ratings or the matchmaking ratings. I can plot the kind of histogram, or I like to use a kernel density estimator because it's easier to see them. If you use R, if you've heard of R, great statistical package, but there's a nice thing you can do in there. It's just like use a histogram, but you use this function instead, and it kind of plots a nice smooth curve, more like that. So I can plot curves like this for Protoss, Terran, and Zerg, and just see where they're sitting in terms of the whole population. That doesn't tell me anything about the matchups, but it does tell me if say, Zerg is has a little skews, a little bit higher skill than the rest of the races. But you might be surprised if it did or not, because, like, for example, Zerg has a very different mechanic to play than Protoss and Terran, so you may expect that players that are a little bit more interested in the game, or a little more hardcore, will try out Zerg and have better skills or things like that. We look at the data and try to come up with hypotheses that fit in. Several of them usually, actually, because there's usually more than one.
Have you ever considered that to run part of the calculation virtually, so that maybe will speed up the ranking performance?
The calculation that does the rating updates really fast, so we haven't needed any additional performance power to do that one. I mean, unless you're talking about what we don't do is so I update your skill once after every match. What I don't do is then go back through and smooth from the beginning to the end and say, oh, wait a second, so you beat this guy up here, and back then we didn't think he was very good. Later, this guy turns out he is really good, so if I looked at this data back here, you might be even better than I think you are now, because you beat a guy who I thought was bad, but now I know is good. I'm probably losing half of you. We don't do that. We could do it, maybe. That's just a lot of data to store. The other, it's more of a data, I think, storing all those matches. The other issue with that is I kind of think players change over time. And if I did that, I can't tell if at that time that guy really wasn't very good and he just got better. So, but yeah, no, we haven't had to do anything like, the math to update a rating at the end of a match to do the updates is pretty fast. It's not that bad. I mean, the worst part about it is the normal cumulative distribution function, which still, you can do a lookup table for if we really needed to. But when we're doing that update is done on the game server, which is not as high under load as, say, the master server where we're doing all the matchmaking. So the engineers get irritated if I want to do cumulative density function evaluations in the matchmaking server, in the global optimizer. So anyways, yeah.
At your experience at eBay, did you use any matchmaking mathematics similar to what you described here for fraud detections? If not, do you see the ranking application being applied outside of the game industry?
Outside of sports, maybe not so much. But I mean, the place where you read most of our ranking these days is web, like relevancy ranking and ad ranking and things like that. You see a lot of, and they could use similar models, and some people do. A lot of people, for those, actually use more like classifiers that even neural networks or boosted decision trees that kind of just predict the quality of a search return result. At eBay, so like I said, these methods are you can cast what I do here into a logistic regression problem, and you can use logistic regression to detect fraud. In my experience at eBay, logistic regression was never able to do better than neural networks. Neural networks did much significantly better than logistic regression. So I put neural networks in eBay because this is not necessarily to matchmaking, but because that's where I have the most experience with. You can use support vector machines, random forest, whatever you want. But we actually hired some interns to try a bunch of different methods, and none of them could beat the neural networks. They could time them, I think, to get close. And once you have something in place that works pretty well, you can stick with it. Unless they're convincing reason why not. So these methods do have a similar flavor to logistic regression, program regression, and you can cast them as neural networks if you want. As for just plain ranking at eBay, I mean, this is all pairwise type stuff. So anytime you have a pairwise comparison, you can use these types of methods. Taste testing is a common place. I think we've got Coke and Pepsi, and drink one, and then they can use the same math to decide what is better, Coke or Pepsi. And basically, Coke has a rating and Pepsi has a rating. They compete by your previous taste tests. So there's some kind of strange applications of this where you go to a website, you see two pictures, and you pick which one you like better. Hopefully, like mountains and pretty landscapes or whatever. Often not used for that, but you pick which picture you like better, and then it puts a rating on the picture. And there's a paper out there, I can't remember who did it right now, where he did a big kind of analysis of using ELO or Gaussian density filtering, and then he proposed a new one, which was closely related to, if any of you are familiar with recommendation systems, single value decomposition, Netflix channel type stuff. So that's another area you can use ranking. Ranking in groups, I mean, you can one of the military applications for when different platoons are doing war games. But I don't usually move soldiers around different platoons.
Yeah. How well do these handle players who maybe suck for a couple years and then get good? Does it usually match them pretty well?
So it's the fastest at the beginning when you first start out. But there's a variable you can tune in here, which is how much do you think they can move around later. So it takes longer to detect that you've gotten better, but it can still detect. So yeah, if you get drastically better over the course of several games, you'll get back up there. You can go from, I'd say, kind of mid-range bronze, olive to diamond. So how many games would that be? Maybe 60 games, something like that. So it's a lot of games, but the nice thing is if you're getting better, you probably didn't go day to night better. You probably slowly got better, and so it'll track that slow movement. That, which is kind of what it assumes. The model we use right now assumes that when people do get better over time, but that how much they get better is a small amount per match. If you had this kind of thing where suddenly you're way better, it doesn't. A lot of these systems like this, you'll find an experience with kind of linear systems and stuff, and even neural networks, is that if you think of this error surface, which represents how correct your system is, and if it's really correct, you're down low. If that error surface is not continuous, if you have this thing where something got way better, then your error will spike up. These types of methods struggle unless you have some way of explicitly handling that. So I've tried to come up with methods that detect when players are playing significantly different than they usually do and changing the system for a brief period of time. If you're studying linear dynamical systems, I think that's called a switching model. So if you are curious about that, it's something I'm very interested in. If anyone wants to do research on ranking systems, is can you do a ranking system with a switching model?
Yeah, but, going along that, so with a system that employs if you start winning a whole series of games, then each game becomes worth more, like a placement match at the beginning. Would that still be balanced and the fair EO?
So that would be the switching model right there. You're saying you just came up with a model. Your model is if you win a bunch of games in a row, I should switch to this new model. I say switch to this new system where now I'm either using the same type of system all over again, but I'm assuming that I don't know where you are anymore, I'll start you all over, or using some other math or some other way to figure it out. So you could do that. And yeah, if you do it right, it's fair, but that's the trick. It's like the math that is used for these systems is very tight. So if you're going to change the math, you need to understand the math behind the system very well. Make sure the new math you're integrating into this, make sure that whatever new math you're using to do this kind of model switching is not going to cause your system to diverge. It's not going to cause your ratings to go all over the place. And you want to kind of have probably some mathematical proof boundary on that if you want to feel confident in using it, or at least run a lot of simulations using close to real data as we can. Yeah?
You mentioned several times the importance of it being fun in addition to effective. How did you go about testing that while you're working on it? You don't have thousands or hundreds of thousands of people.
Predict fun?
Or test fun, at least.
So when I was with Enemy Territory, I had usually about 32 people I could play with. Yeah, and so that was great because I could rapidly iterate and try new things. And in Starcraft 2, I have to kind of do a lot of thinking and then simulating. So simulate the experience of what a player would feel like on the ladder and actually print out, well, in code, not actually on paper, you should print out, hey, this is what the ladder would look like after one iteration, two iterations. Is this fun for the players? Let's track a single fake player through the system. So I'm writing lots of simulation code. That's one of the ways to go about it. There's gut instinct, experience. There's talking to the designers around you, asking them what they think of their experience of other ladder systems. You study other ladder systems. And at one point, you got to go into beta, you release the game, and you want to, and at that point, study closely how the players are reacting, look at their feedback, and use them. So now you have real data. You don't need to simulate. You can actually use their play experience and run it through new systems with real data. It's still kind of simulating, but it's using real data and seeing, well, where would this guy end up if I ran this new system on it? So yeah, there's a lot of things like that that are important to do. After writing a lot of the system, you get a feel for it. And you kind of get a feel for both the math and how that dynamical system is going to evolve, which is important as a ladder design type guy. When your lead is asking you questions like, hey, why don't we try this? You need to be able to say, think in the back of your head, you need to convert that to the math behind that to the fun. You say, okay, well, what's going to happen to that player if we do that to him? Is that going to be fun, or is that going to be way worse for the player? So for instance, there's a variable we have, and I toyed with using, which basically says, instead of making super tight matches, I can consider any matches within this range or this range or this range tight. Just as tight as a perfect match. And I could play with that variable, make it so that not every match is super tight, because there's just somewhat of a theory or feeling that if every match is like super tight, it gets you get this fatigue where every match is to the wire, every match I could have won. Whereas if I widen it every now and then, where sometimes you get matches where you just get stomped, but the pain's over quickly, and some matches you get to stomp them, and as long as you do that fairly, then the question is what's going to happen to overall if you do that. And in the whole entire system, you got to consider, if you do stuff like that, will you have too many players in this kind of crazy state where no one is getting match-made fairly anymore, and all the matchmaking is bad. So anyways, there's a lot of things to think about a lot of my job is converting the math quickly in my head to what's going to happen in this dynamic system for the players.
I think we should.
Okay.
Thanks so much.